Equality is good, but it's better in chemistry. So let's start with how to balance a chemical equation, and Mr. Shangus is going to help us too. Hello, Mr. Shangus, how are you? Yeah, you're getting fatter. Anyways, so let's start with balancing equations. If I give you this equation here, you know equations are very important in our life, industrial life, because you can determine the amounts of products, you can determine the amount of any chemical that you need to make another chemical. So if you want to make a chemical reaction, as we see here, the atoms should be equal in both sides. What do you mean by this? It means the number of atoms in the reactants should be equal to the number of atoms in the products. I didn't understand till now, so let's start practicing. Here, let's start with potassium. Potassium in a compound here. So we just want to compare the number of potassium atoms in the products and the reactants. So how many potassium atoms here we have in the reactants? We have only one potassium atom, right? What about the number of atoms of potassium on the other side? We have only one, so everybody's happy. So the number of atoms of potassiums are equal, which is good. Alright. What about chlorine? Chlorine atom has only one here, and we have another one here, so it's okay. The number of chlorine atoms is balanced. Alright. What about oxygen? Here we have 3 oxygens, and here we have 2. So the number of oxygen here is not equaled. So what to do here in this case? Actually, we don't have a common number between 2 and 3, so we just make alternating multiplications. We want to multiply the 2 oxygen here by 3 and the 3 oxygens by 2. But wait, when you multiply the number of oxygens with another number, you multiply the whole compound. So here we multiply the whole compound, which is potassium hypochlorite, and here we multiply the oxygen by 3. So when you multiply by 2, it means you multiplied K, you multiplied Cl, and you multiplied oxygen. So let's take a look on the changes. Here we have K, which is potassium. Potassium atom becomes 2. See, here we have 2 potassium atoms, and here we have only 1. So what to do to make the number of potassium equal? We just multiply this molecule by 2. As we told you, multiplication by 2, it means the whole compound is multiplied by 2. So we have 2 potassium atoms. What about chlorine atom? It's multiplied by 2. So here we have 2 chlorine atoms. Alright, and here we have 2 chlorine atoms. Everybody's happy right now. So what about oxygen? 2 multiplied by 3 oxygens leads to give us 6 oxygens, and here the same. So this equation here is balanced, and it's okay, you can write, and everybody's happy. So we have a beautiful equation. Let's start balancing. Here we have 1 lead atom, and the other side of the equation we have only 1 lead atom. So the lead atoms here are so happy. Let's talk about OH by 2. Hydroxide by 2, it means we have 2 hydrogens and 2 oxygens. So here we have 2 oxygen, alright, but here we have 1, okay, and we have 2 hydrogens, alright, and here we have 2, so the number of hydrogens here is good, maybe just like temporary. So what to do here to make 2 oxygens? We just multiplied H2O by 2, so the number of oxygen become balanced, alright, but here we have 2H2. When you multiply 2 hydrogens by 2, it leads to be 4 hydrogen atoms, and when we multiply this compound by 2, it leads to give us oxygen 2. Alright, so as we see here, we have 2 oxygen and 2 oxygen. But wait, we have another hydrogen, and hydrogen here in the reactants. So what to do in this case? The number of hydrogens in the reactants, we have 1 hydrogen here and 2 hydrogen. The overall is 3 hydrogen. Alright. But here we have 4 hydrogens, so the number of hydrogen is not balanced. What about chlorine? It's not balanced too. Here we have one chlorine atom, but in the other side we have two chlorine atoms. So what to do in this case, we just multiply HCl by 2. Alright, after multiplying by 2, hydrogen becomes 2 and chlorine becomes 2. Alright, so let's count the total number of hydrogens in both sides. Here we have 2 hydrogens and here we have 2. So the overall hydrogen atoms is 4 hydrogens. Alright, and here we have 4 hydrogens, which is balanced. Here we have 2 chlorine and we have 2 chlorine. Here we have 1 pp and we have 1 pp. So this equation is balanced. I just want to say something about balancing equation. It is full of trying. You have to try. You have to practice more. You have to try and then try because the number changes.